Solve. All right, in this video, we're looking to solve exponential equations. Let's look at the first example here. We have 3 to the x is equal to 3 to the negative 2. Well, if the base for both of these expressions is 3, then the only way 3 to the x can be equal to 3 to the negative 2 is if what? X is equal to negative 2. And so basically, whenever the bases are common, you can just drop the bases and set the exponents equal to one another and solve the resulting equation. Now, this equation is already solved for us, basically, so we're done. All right, looking at the next one, example B, it's the same kind of thing. First thing we want to do is find a common base, though, because once we find the common base, we can then drop the base and set the exponents equal to one another. So let's try to rewrite it so we have a common base. I know there's something in common between 5 and 25, isn't there? I can certainly say that 25 is 5 squared. So I should be able to rewrite this as 5x squared is equal to 1 over 5 squared raised to the negative 8th power, right? And then from there, I should be able to rewrite it again. I'll keep the 5 to the x squared power here, but I should be able to bring this guy up, right? And when I bring it up, it happens to make the exponent negative, right? So it'll be 5 to the negative 2 power, and that's to the negative 8th power outside. Then I can remember my rules for exponents, which says what? Something like this allows me to multiply the exponents, correct? So raising a term to an exponent means you multiply the exponents for the term and the power that you're raising it to. So if we have 5x squared, that'll be equal to 5 to the negative 2 times negative 8, which is really just positive 16. And then once we have that, we've finally got it written in a common base, right? We can finally say that they're both base 5, so I can drop the bases and set those exponents equal to one another. So I can say x squared is equal to 16. And then if we have x squared is equal to 16, we know that when we solve that, we can say that x is equal to plus or minus the square root of 16. Basically, I took the square root of both sides, right? And that'll mean that x is equal to either plus or minus 4. So two possible solutions for this one. Both will work just fine. All right, let's take a look at example C then. For example C, same kind of thing. It's a little more complicated looking, but not much different in terms of the strategy. We want to find a common base. So I can see that 3, 9, and 27 all have a common base of 3. So I can rewrite it as 3 to the x is equal to, the 9 can be written as 3 squared, right? And that's raised to the x minus 1 power. Now the 27, that's 3 to the 3rd power. So I can write that as 3 to the 3rd, and that'll be raised to the 1 minus 3x power. Now from here, we have to remember that rule which says what? When you're raising a term to a power, you can multiply the exponents. So we can say 3 to the x is then equal to 3 to the 2 times x minus 1 power times 3 to the 3 times 1 minus 3x power. Again, using that multiplication of exponents rule. Now, from there, the bases are all the same, so we should be able to drop the base and then end up with an equation that says x is equal to 2 times x minus 1 and 3 times 1 minus 3x. But what do I put in here? That's the question mark. What goes between those? We had multiplication here, so what we want to remember is this, and that is that when multiplying common bases, you do what to the exponents? For example, if I had y to the 2nd times y to the 3rd, I would say that that's y to the what? 2 plus 3 power, right? So same thing here. Common bases being multiplied, it means these exponents should have had a plus sign between them, so I'm going to actually put a plus sign between those. Okay, now from there, finally, we have our equation. X is equal to, if I distribute in my 2, I'll have 2x minus 2 plus 3 times 1, which is 3, minus 9x. And then from there I have like terms. 2x and negative 9x will give me that x is equal to negative 7x. And then negative 2 and 3 gives me plus 1. Now I want to solve, so I'm going to bring the 7x over to the other side. Call that positive 7x plus x is equal to 1. So finally we have 8x is equal to 1, or in other words, that x is equal to 1/8 if I divide both sides by 8. And so my answer for this one is x is 1/8.